My name is George. This course will basically be working on different Python problems. We'll be trying to understand different data structures, how they work, and different algorithms and how to apply them for each situation. So we know that data structures are in two types. We have built-in data structures. We have user-defined data structures. User-defined data structures may be stack, queue, hash maps, graphs, and so forth. But for this video, I'll just be focusing on built-in data structures, which include I'll just type them down. List. We have tuple. We have dictionaries. We have set, right? So we know that each data structure has different properties, right? So if each data structure has different properties, then we'll need to understand that to decide what type of data structure to use for each problem. So I'll start with lists. We know that lists are mutable. We know that you can index your list from 0 to the last element. So for instance, if we have a list of 10 integers, and I ask you what's the last element, to understand what's the last element, you need to refer to your indexing. Indexing starts from 0, so your last element will be 10 minus 1. So if a list is a list of n numbers or n elements within it, then your last index will always be n minus 1 because your indexing starts from 0. We also have negative indexing that starts from negative 1. We'll do a simple example here just to create a list. Let's say we have a list of ages and names of students in a classroom. Ages and names in a classroom. And within a list, use the square brackets to create a list. Say we have 23. This is just random ages of different students, and I'll include names just to have different data types because a list can include different data types. We have table. We have, let me say another student is 34. We have person. And to view your list, you use your print statement, ages and names, right? So this will give out your list. See, we have that list created of different ages, 23, 44, and names of students. We have George, Tabo, and the age 34. This is just random names and random ages, right? Say we can have an empty list. Can we be able to create a list with nothing inside? I'll create the same list, say age and names. I'm just going to use an to be quicker. So we have an empty list here, right? Let's see, can we be able to print out this list even though it has nothing inside? Here, yeah, we're able to print this list. Earlier I mentioned that a list can be mutable, so that means you can change whatever is inside, or you can iterate through your list. Say we need to add something in our list, or we need to delete some things in our list. Can we be able to do that? So what we can do is let's say we want to add an age within this new empty list. We can say an use append the new age is 66, an older student, and we print this list. Print an. We have 66. Yeah, here the empty list now has an age within it, 66, right? We'll go to the next data structure. Let's jump to tuples. Tuple. So the difference between tuples and lists is that tuples are a bit faster than lists, but then the issue with tuples is they're not mutable, right? Let me say an1. So to create a tuple, we use this type of brackets. You can also add whatever you want to add inside. I'm just adding random numbers. Ages, let's say it's ages 34, 44, 54, 66, 34, and print it. So if it's not mutable, that means you can't add or remove whatever you have in it. So it stays as it is. Use the same print statement. tuple an1. There you go. And another data structure is dictionaries. This is a more interesting one. You'll see why I think dictionaries it's a more interesting one. So with dictionaries are mutable, similar to lists, but here's the best thing. Here we have a key and an element. So within dictionary we have a pair of values. For instance, let me show you an example, just to make it easy to understand. So an2 is equals to, and here we use the curly braces, the curly brackets. So we can say someone tells us the list you had before here of names and ages, you can actually tell that or they tell you that 23 it's George's age, 44 it's Tabo's age, and 34 it's Kirsten's age. So in your dictionary you can actually put key and element as an age name, like let me say 23. Say 23 it's a age, George's age, and 44. Say that's Tabo's age. Then we have 34. So that's Kirsten's age. Let's print this and see if we'll be able to get our tuple to run. So we have our dictionary. There we go. So we have everything linked. We have a key, a pair of values within our dictionary. So this data structure is mutable. We'll jump to the last one, which is sets. Right. So the sets are mutable. So it's still basically an ordered collection of unique elements. But here we use this type of brackets. Let me show you an example. An. Remember, an is just ages and numbers, ages and names. An3. We use the curly braces for this one, but it's still similar to. Let me do this. To what we had before. Let's print out. We'll set and see. We'll get the same thing. An3. Right. Perfect. So these are just different types of data structures, and I think the more we dive into different problems, you'll see how you can use them, how you can apply them, and how you can play around. Right now I just gave you a summary. Now you know which ones are mutable and which ones are not. So within certain problems you'll see how we get to play around.